In this video, we're going to talk about how we solve quadratic equations by graphing. If we have the equation y equals x squared plus 2x minus 8, and they're asking us to solve this, we always solve equations when our quadratic is equal to 0. So if I substitute a 0 in for y, what I'm really doing, if I think about that graphically, is I'm trying to find the spot on our graph where our y value is equal to 0. Well, here's the graph of our quadratic, y equals x squared plus 2x minus 8. And if we look at this and we're trying to figure out where the y value is 0, well, on a graph, y is always 0 on the x-axis. So I'm essentially trying to find where my graph crosses this green line that I'm highlighting. Well, if we look at the picture, we can see that our graph crosses the green line at 2, 0, and again at -4, 0. So according to the graph, y is 0 when x is 2 and when x is -4. So I'm going to show you really quick how this relates to what you've already done with solving by factoring. If I were to solve this by factoring, we would end up with x plus 4 and a minus 2. So if I set each factor equal to 0, we would end up with x equals -4 and x equals +2. Well, those are the exact same values that I got for our x-intercepts, -4 and +2. So basically what I'm saying is that the real solutions to quadratic equations are the x-intercepts of its graph. So now we can solve quadratics without doing it algebraically as long as we have a graph to look at. So let's take a look at another example. Again, if I'm trying to solve this equation with a graph, we know we're looking for when our y value is 0. So we're looking for the x-intercepts of the graph of our quadratic. Well, when I'm looking at this graph, we can see that our curve crosses the x-axis at -1. And again, right here. Now that looks a lot like 1/2. We'd have to solve it algebraically to be 100% sure. So we could solve by factoring or with the quadratic formula. But our solutions, according to the graph, which I did solve it by factoring and it is correct, would be -1 and 1/2. Let's look at another example. If I'm asked to solve the equation, or if I'm given the quadratic equation y equals x squared minus 2x plus 1, we solve when our y value is equal to 0. So again, I'm looking for those x-intercepts. So if I take a picture of my graph, and I want to know where does my graph cross or touch the x-axis, that only happens right here at +1. So the only solution to this equation, according to my graph, would be x equals 1. We can verify that by solving it algebraically, either factoring or with the quadratic formula. Let's look at one more example. We're asked to solve this equation. So remember, we solve quadratics when they're equal to 0, so we're finding the x-intercepts. That's when our y value is 0. So if I look at a picture of our graph, we can see that the x-axis is right here, and my curve starts below it, turns around, and goes back down before ever touching the x-axis. So according to this graph, it doesn't have any x-intercepts, which would mean that our quadratic equation has no real solutions. If we were to have solved this algebraically using the quadratic formula, we would have found out, based on the discriminant, that we don't have any real solutions because our discriminant would have been negative. So when we have no x-intercepts, we have no real solutions. So the big idea from this video is that to solve a quadratic equation graphically, the real solutions are the x-intercepts. And again, that's because we always solve an equation when it's equal to 0. So we're finding on the graph when y is 0, that's always an x-intercept. And that's it.